So we're going to do a few questions from this midterm exam, starting with question number 2 on double hashing. Okay, so so we want to calculate first what is the average successful search length. Okay, so what do we need to do for that? We need to calculate the start point for each of the values. Okay, so we have the values 41, 6, 32, 9, 20. Because we're not doing insertions, it doesn't matter at what order we're writing them. And we want to do the start, to calculate the start point, start, step, and length. Okay, so what's the formula we need? The length of the table, the size of the table is 7. So so if v is the value that we get, then start is equal v modulo 7, and step is equal to v modulo 5 plus 1. Okay, so let's see. So for 41, we have that the start is it's modulo 7, so it's 6. And if we look, 41 is actually in 6, so we don't need to calculate the step, and the length is 1. For 6, the start is 6, and we don't see 6 here, so we need to calculate the step. The step for 6 is modulo 5 is 1, is 2. So we take 2 steps down from here to here, and there is the 6. So we have two steps, two places we're checking. 32 mod 7 is 4, and 32 is not in 4, so the step size is 3. So we go in 4, 1, 2, 3, so that's again 2. 9 is 2, and 9 isn't 2, so it's 1. 20 is 6, so 20 is not in 6, so we need to calculate the step. It's 1, so so we get that that is 2. Okay, so the average length is the sum of these lengths, 1 plus 2 plus 2 plus 1 plus 2, and we have a total of 5 steps, so this sum is 8 over 5, which is also equal to 1.6. Okay, now we want to calculate the average unsuccessful search length. Okay, so the unsuccessful search length is obviously for things that are not in the table, so we can't find them. And how are we going to average over those? Well, we're just going to take the average over all possible step lengths and the average over all possible start points. Okay, and as the start point is modulo 7, it can have the values 0 to 6, and the step is modulo 5 plus 1, it can have the values 1 to 5. So so what we do is we generate a table where we have here the on this side we have the step, and that goes from 1, 2, 3, 4, 5, and on this side we have the start, and that goes from 0, 1, 2, 3, 4, 5, 6. Okay, so now let's see, if we want to see how long the search is, then first we want to look here and see, okay, 0 and 3 are empty, so for them the search length is just 1, 1, 1, 1, 1. Okay, for 1 it's occupied, so the step size matters, and the search is always going to be more than 1. So let's see, with step size of 1 we start here, so we do one check here, and the second check here, 2. Okay, so that gives us a 2 here. Okay, let's okay, now we want to check 1 with a step size of 2, so we have here we start here with 1, we take 2 steps down, 1, 2, that's still occupied, so we take 1, 2, get 3, it's still occupied, 1, 2, 4, and 1, 2, we get to 5. So this one is 5. Had to check 5 places before we could find the empty place that tells us that the element is not there. Okay, what about 3? And with okay, so what about 3? So we have again 1, let's see, 1, 1, 2, 3, 2, 1, 2, 3, 3, 1, 2, 3, 4, and 1, 2, 3, 5. So that's another 5. Okay, so what with 4? 1, going down with 4, it's 1, 2, 3, 4, 5. So this one. Now we have going down with 4, so it's 1, 1, 2, 3, 4, 2, 1, 2, 3, 4, 3. So this one is 3, and so we have 1, 1, 2, 3, 4, 5. That's 2. So that last one is 2. Okay, so in this way we can basically fill in the whole table. So what we want is to average all of these entries, so we do it by first summing along the rows, so we get 5, 17, 18, 5, 17, 17, 19, and then when we sum all of these together we get 98 divided by the number of entries, which is 7 times 5 is 35, and so that gives us 2.8.